Newton has a third law called action-reaction. In his Principia, he said, to every action there is opposed an equal reaction, or the mutual actions of the two bodies upon each others are always equal and directed to contrary part. Okay, that what it means. The object gives a force to another, then receiver return the opposite force at the same magnitude. Okay, when you learn this in the physics class, well, it's a law. You are not supposed to argue, but at least you should come up with a question. This is easy to observe in his daily life, the Newtons. But why it's fundamental law? It's everywhere, too abundant. Why it's abundant? You know, actually action-reaction is atomic level interaction. But Newton didn't know about atoms. He just observed and this must be it. But why this is fundamental? Why so important? Did he know where it comes from? Well, actually, he was lucky. He identified this. That's why he was genius. The genius sometimes get lucky because of their genius. Okay, the action-reaction actually come from the conservation of momentum, the change of momentum by collision during the exchange of force. Okay, you know the momentum change is the force applied integrated by the collision time. So if this collide another, there is a force applied, so it's lose momentum. This guy gain momentum, so loss and gain should be equal. That's the conservation of momentum. If that is more fundamental, then we can tell this force is same as reaction force and opposite, and that's what action-reaction law, the third law, is about. Okay, the conservation of momentum and the third law is equivalent. It's not really totally equivalent, but they are the same thing they're talking about. One mass pushes another with a force F for the duration of time delta t. The pushing mass loses the momentum. Since the other side received the same amount of momentum, conservation of momentum, during the same time, the exact opposite force must be applied. So action-reaction come from the conservation momentum. So Newton's third law, conservation of momentum, we're talking about same thing. Okay, so which is more fundamental? Okay, conservation of momentum is more fundamental than the action-reaction. Why? That's a kind of question you should ask the physics teacher. Action-reaction works only for mass collision. You need to have a mass, and that's Newton's time. That's the only physics. The physics is about mass. Now, photon and microwave has momentum too, and they conserve the momentum. Okay, so momentum with mass and without mass. Conservation of momentum works for both, even with mass, without mass. Okay, but action-reaction we're talking about is only for the mass. So you can tell which is more fundamental. We need to get into the relativistic world. It's the Einstein special relativity. When you get into that details, you will see energy is momentum c, the light speed square, plus the static mass m0 c square and square. Okay, now this is E equals mc square, but the photon doesn't have static mass, no mass. Microwave doesn't have it. So only what it has is momentum p. Okay, so kinetic energy of photons or microwave, the energy is given by the momentum times light speed c, and that is conserved. Okay, that means you have some kind of rotating fan and you shoot the photon, then this start rotating. Have you ever seen the Compton's demonstration in the vacuum chamber? You shoot a photon, these things start rotating because photon has momentum. Okay, so what's happened is the momentum of photon or microwave is given by this conservation of momentum hold in the world of no static mass. Without mass, it's hold. So momentum conservation law is more fundamental. It's just special case action reaction. The Newton's claim is correct, but that's for the case that we have a clear mass. Okay, so when you talk about, okay, this is Newton's law, you have to understand that was the law when Newton invented, but classical physics already advanced way beyond that. Okay, and we defined more fundamental law. Okay, I hope you enjoyed listening to these videos. Please check out the videos, and if you like, click subscribe.